Hello. So continuing with the previous model, we have seen the DC behavior of this diode circuit, and we had used the models of the diodes, specific models from the manufacturers. What if we don't want to use the model from the manufacturer? We want to use the general model of a diode. So because since we have used the specific manufacturer's models, it had a different properties such as cut-in voltage and all. And because of that, our theoretical results were not exactly same to the simulated results, because we are using the manufacturer's models, and the cut-in voltage and some other properties of that specific models were different. What about we just want to use the generalized model now? So what I do is I click the diode and I select this diode part here. I place it here. Look at this name of the diode. It's a diode D2, and the model name is D. It doesn't have any part number, unlike this, which has a manufacturer's part number and name of the diode. This is diode D1. So instead of this manufacturer part, we use the generalized part. Okay, and we'll try to see if we simulated this behavior of this diode in this circuit, whether it matches the theory results that we have seen in the previous model. So don't forget to refer to the previous session where I have used the PowerPoint to draw the circuit diagram and do the theoretical calculations, such as the current flowing through the circuit, the voltage drop across the diode, and then the drop across the resistor. Okay, so what to do and how to do is simple. Take the scissor, put this part, cut it, press escape button from the keyboard, then take this part, which is the move, and then click here on diode D2, take it inside the circuit by moving your mouse, and then press Ctrl R to keep it moving the way you want. We want it to be in this direction. And once you do that, click mouse button so that it places your circuit, your diode inside the circuit. Press space bar from the keyboard. So if the circuit is mismatched from the center of the screen, it will get aligned there. So rest of the things are same. See, voltage source of 1 volt DC. Labels of the nets are V in here and V out. Resistor R1 is same. We are running the DC analysis, which is done by putting the .op command. And once that is done, click save here. And let's see what's the spice netlist looks like. So right click this schematic window and then see view. Go to spice netlist. And now you see here the netlist is there. V1, R1, D2 diode is connected between V in and V out and D. And see, instead of in the previous session, we have seen there was a part number here of the diode, but now it's the general model. Okay, so when you don't see a part number, you can use the general model. So it has a cut-in voltage of about 0.66 volt that we want to verify now. Okay, and rest of the things are same as explained to you in the previous session. So close it, click run. And now you see here, V in is about 1 volt. Output voltage is 0.37 volt, exactly same as what we calculated. So refer back to PowerPoint. Let's see if you can see that. So V out was about 0.67 volt right here. No, 0.37 volt. So 0.37 volt right here. You see 0.33 we calculated right over here. And current flowing through the diode and the resistor R1 is about 0.37 milliampere, which is approximately what we calculated. So these are the simulated results. So you see these are same. So again, right click the schematic editor and go to view, and now click spice error log. So we'll see what information it gives us. So it says that direct Newton iteration for dot OP point succeeded semiconductor device operating points. So operating points is what we want to need. What is the semiconductor device here? Only the diode. And name of that diode is D2, model is D, and the current is about 371 microampere, which is when forward bias flows through the diode. VD is the drop across the diode, which is about 629 millivolt or 0.629 volt, which we calculated from our circuit. And yeah, so there is no capacitance here because it's an ideal diode. There is no capacitance here. We'll see what is this R equivalent resistance. It's about 698, 6.98 into 10 to the power 1. So we'll see that. So it's basically the series resistance of the diode. We can assume that, but we'll confirm this again. Okay, and rest of the information is about temperature at which the circuit is being simulated or solved, and that's all. So you see, this is how we can match our theory results with the simulated one. So this was just to give you a brief overview about how we can use the general model and the specific model from the manufacturer to use different devices and components in our circuit. So refer back to previous modules also to understand this particular session.